right as the stream starts, Tico. Okay. Welcome back to the stream, folks. That was just Tuco leaving. Hopefully he'll be back. If I had to guess, he probably just has to go use the bathroom or something. He seemed to be enjoying this spot he was in. Alright. Welcome back to the stream here. So yeah, this will be a relatively quick stream, getting started super late here relative to, I don't know, I still don't really have an official schedule or anything. I've been often starting them in the afternoon here, but we're in the evening. This is a little later than usual. Anyway, I spent most of the day redoing a bunch of my infrastructure here. I have a couple of Windows machines that, among other things, run OBS to do the recordings here, and the one with the most CPU cores and RAM is what I usually use for editing videos. And I was just going through the process of finally getting rid of Adobe and getting rid of Windows and switching to Linux on there. I don't want to get into a whole like bike shed thing, but it seems to be an improvement for now. Tuco wants back in already. Tuco, you want back in already? Hey. But yeah, I've finally got it actually working pretty nicely over here, doing my other recordings. Anyway, because of that, I think my plan A for today was to repair this cable so that I can put this whole contraption back together. It's obviously a little bit unwieldy as it is. This epoxy I have seems to be usable, but it's taking way longer to cure than I expected. So, I figured we'd give it another test just to see where it's at right now. I think it's probably good enough to use. My plan for repairing this cable is really just to put a little smidgen of this on top of some of these connectors, or some of these silver traces that are tarnished or damaged but not actually broken, just to protect them. And then to actually repair the touchscreen by adding 1 or maybe 2 jumper wires between these metal pins here at the front of the connector and that same epoxy that we put on the silver ink. So it's going to be really fiddly. I don't think I have the patience to do this late at night here, so I think I'm going to save this for tomorrow. And I have a plan B for today, which is to do a little bit of lazy reverse engineering. So yeah, I'm going to briefly poke around at this trace though, just to see, or not this. I'm going to save this whole thing for tomorrow. I don't want to be messing with this when I'm trying to do like a relatively short stream, because I expect this to be kind of a pain in the butt. These are fairly weak. It's a kind of a thick plastic sheet substrate with these fairly delicate silver traces printed on it using some kind of ink that's basically like silver particles and a binder. And then there's a thin layer on top of that that's just thinner than like a plastic food wrap, maybe a little bit thinner than a typical like packing tape. And I tore that in a line here on a previous stream so that I could inspect some damage. That was actually already coming apart because there was a fold in the cable from how it was installed, and the covering had come delaminated right there at the fold over the 20 years that this thing has been assembled. So that seemed like a problem area, but more importantly, at the time, it was a place where I knew I could open it without causing too much additional damage so that I could do some testing. And then the actual problem, I think, is localized to this connector. It's just kind of a difficult construction to repair. I've got this taped down a little bit, but this is like a 0.1 inch female header that plugs into regular old header pins here on the circuit board. And I already checked out the whole rest of the path between these header pins and the controller chip for the touchscreen, and that all seems fine. And then I found a way to test this reliably after reading a bit more about how these touchscreens are constructed, so I could test the voltage or the resistance between the excitation and the sense pins, which come in these 4 pairs. So that revealed 3 pairs that have a nice low consistent resistance around 20 ohms, and then 1 pair that's just all over the place and often around a mega ohm. And so I wanted to figure out whether that was a damaged part in the touchscreen panel itself, which would be extremely hard to fix, maybe, or whether it was something in the connector. So it does look like it's mostly a problem with the connector, although even measuring the touchscreen from this end, it's not quite the same as the other 3 pairs. So there might be something slightly degraded about the touchscreen itself, but the big problem that's actually keeping this from working most of the time seems like a bad connection between the printed trace and the little metal clip they use here. So yeah, that's the slightly damaged trace. Oops. So I don't quite know what's going on here, but it looks like these are just individual strips of metal that are continuous down into the socket here. So I think this is just like one stamped piece of metal. And then I think when they put all this together, there's a crimping tool that punches this kind of half circle down in, or maybe these are 2 bite marks. Yeah, it's actually like 2 crimps, like one on each side. So I think they have a tool that just punches those in, and those puncture, I assume, that top layer. Maybe they peel it back and then make a connection through to the ink on that bottom layer. So I don't know how that failed, but somehow it failed. I don't know that we are really going to see the inside of that, because it probably makes sense to just leave it intact and try to bridge across the broken section than to disturb the other ones any further. I mean, there may be alternatives to this, like maybe I can find a replacement for this connector and then just like cut this off and crimp a new one on. That seems like the cleanest way to solve this. It's just that involves finding a bunch of esoteric parts and tools, and so that becomes a shopping problem. And I'm trying to keep this from being a shopping problem. Like, I have all this glorious e-waste that I can transform on stream without having to buy additional e-waste. We can try to decommercialize this endeavor. So anyway, this is going to be pretty fiddly. I'll probably have to break out the tiny soldering iron, maybe. I don't even know if I want to solder this metal, because that's going to affect the plastic here. I probably need to use conductive epoxy on both sides of this, and then make the connection either with wire or with thin copper tape. The copper tape is probably easier to glue. The wire is probably easier to work with in general. So yeah, that's going to be fiddly. I'm going to leave this alone for a minute. Let's take a brief look at this epoxy mess. Got a good view of Tuco here on screen, or that I've got to get on screen. Of course I need to make a new layout now, because I don't think I have one that has everything except the oscilloscope on it. Guess I also don't have one that has just the cameras and the microscope. Used to, but that was before I redid all my OBS layouts. I was kind of surprised. I copied an OBS config file from this machine that I just replaced Windows 10 with Arch Linux on, and it mostly worked. Like the decklink inputs were all in the same order and everything. I had to change... I think the encoder was the same because it was the same GPU and I was using a GPU-specific encoder. I think the only thing I really had to mess with was there was a Windows-specific input for the USB video capture device, and I actually couldn't even change it in the UI because if I just interacted with the device at all in the UI would crash because OBS is a very well-written piece of software. So I had to go in and edit the JSON to remove all the references to that. Oh wait, no, I tried that, and then editing the JSON, I think it actually just reverted to a previous version of the config file because I did something wrong in editing the JSON. So I don't know what I messed up there. I think I ended up just deleting the scene that contained the broken source because that was relatively easy to recreate and I could just keep all my other scenes and configurations. Computers are bad. So this is the silver epoxy that I have had in my garage. Well, I haven't even had a garage for that long, but I've had this in my garage recently and I've had it in my possession for a while. I don't know when I bought it, but it has a Fry's Electronics label on it, so that gives you some idea. And I was pretty sure it would be completely useless, but it was still liquid and it seems to be hardening, so I think I might still be able to use this. And I don't really want to buy more because, as I was saying in the last stream, it was always kind of expensive, and I think it's gotten even more expensive. At least the stuff I found on a quick search was more expensive than the sticker that was on this from Fry's. So this conductive epoxy is so weird, right? It's like, hello, I would like to buy one conductive insulator. It's the strangest stuff, and it starts out very, like, kind of, I don't know, like it's hard to find any conductivity when it first starts to get solid, and then eventually it gets a little bit conductive. Let's see where this is at. Ooh, yeah, that's getting better. So it's also going to depend a lot on the contact area of the probes. I think to do this properly, I would have a little square of copper tape to do the measurement, but I'm just trying to get a rough idea of, if this stuff is actually any good. And when I do apply this stuff, I am going to need to make sure there's a decent contact area. Yeah, that was in the single-digit mega ohms. That's in the 100 kilo ohm range. It varies a lot though. It's like bouncing around down into 4K depending on exactly how I hold the probes and how I press on it. So yeah, it would definitely be more reliable to do the measurement on something solid. Can I even get a reading across a larger distance? Oh yeah, 8 mega ohms. $50 kilo ohms? Yeah, that's giving me... I'm not touching anything. I shouldn't, am I? Okay, and then if I press too hard, I kind of break through the layer and I don't get as good a contact. I think I messed it up. 5 mega ohms. Can we give Tuco the meter? Cable does not reach all the way over there. bumps and stuff in here. Right, it's like really, really sensitive to exactly how I'm making contact. Like moving the probes apart and getting a lower reading. Anyway, still kind of squishy, right? I put this on about 24 hours ago. I don't think it's supposed to take this long to cure, so that might just be because it's old. So thicker lump of it. That is quite conductive now. Hundreds of ohms for this little thicker chunk of it. What about like a... This is like a hardier but not ridiculous thick layer of the stuff. It's like single-digit kilo ohms when I make good contact. That's pretty good. So probably improve as it cures more, because as you can see, it's still quite squishy. Huh. 180 ohms. Sticky, sticky, sticky. Okay, just wipe this off my probes. So in order to have something relatively chill and quick to do on this stream, I figured we'd just do a little bit of light reverse engineering and answer a small question I had, which is how do you write to the text LCD on this voting machine? Because it would be cool to make a little program that does that. Oh, let's test this ink while we're here too. I was having really bad luck getting any kind of conductivity from this. This is from a different thing. This is like a conductive silver pen, which is also quite old, and it was clogged, and I slightly unclogged it, but it still wasn't doing well, so I didn't actually get very much ink out of it. This is probably going to be a total bust. We are experiencing some white balance on that camera. Yeah, I think I would need significantly more ink than this to get any kind of signal. I'm still just reading nothing on the meter. Ooh. 5 ohms? Oh. That's like a little chunk of the ink that I think came off the pen as I was unclogging it. And that's actually quite conductive. 1.4 ohms. Yeah, if I can actually get this pen to flow, it might be good. Huh. Did any of these lines work out? I don't think this made a continuous path, really. Yeah, that was a bust. Oh, yeah. Yeah. There's a comment in the chat that ribbon cables are very tough to work with. It's a shame they're so useful. Okay. I don't even think I'm going to actually try to turn on the machine and demo this right now because it's not very much fun to interact with this thing without the main LCD, and I don't want to move the main LCD around until I make some progress with this cable that's splayed out right now. But the messages are all pretty easy to find in the binary here. So this was one of the files that was just hanging out there on the compact flash card in the machine. I've probably got databases for it now in IDA and Binary Ninja, and I'm about to start one in Ghidra. Gotta remind myself what this even is. It's some kind of flat binary. I think that's a load address. It's going to be 32-bit x86 code. I was just searching for a string that I knew was in one of those LCD messages. Activate refers to the big yellow button on the machine. So yeah, this binary I think is the only thing in the system that even knows how to write to this LCD. So, you know, like the BIOS doesn't know how to write to it. I doubt there are any like operating system level drivers that they bothered writing. It's probably just something in the application banging on some I/O ports directly. So I expect this to be relatively straightforward. Oh, I got some 16-bit strings. I would not expect the text LCD messages to be localized because those text LCDs have very limited character set support. So these are almost certainly for the main like graphical UI. A lot of these, yeah. Anyway. We could look at the earlier Binary Ninja database, maybe, but that would be cheating. I was going to list up that tar file, but it's not very interesting. There's a bunch of other files in there, but they're mostly like bitmaps and a couple of, you know, like binary configuration files and stuff. Like basically the whole application is just linked into one flat binary here. I'm assuming abs is for an absolute like, positioned binary of some sort, like as opposed to a relocatable object. It seems to have a really simple header. Tuco looks more comfortable than I will ever be. This is the driver we were working on last time. I don't actually need this now. Okay, looks like I already loaded this. I don't know if I loaded it correctly or if I was just messing around. I was probably just messing around. Why are there no memory segments? Yeah, I don't know what I was doing here. I should redo this. Yeah, there's probably a better way to do this, but I'm just going to delete this and re-import it. So I don't know what I was up to. No idea what keyboard shortcuts Java's file import dialog would even want. Trying to guess where the header ends and the presumed flat binary part of this begins. If we don't see any good clues, I think it's safe to just import it at the default and then move the segment. Like, Ghidra actually seemed to be pretty good at moving segments. Oh, are those 32-bit pointers? Yeah, I think we can do all of this more effectively in Ghidra. So let's just leave that default, I guess. Sorry, I was just dealing with some Twitch spam. Oh, was this just the state that it loads in for a flat binary? Do we have to manually define every segment? Huh. Did I just close this by accident? Okay, I don't know why that opened with a blank program. This is more what I was expecting. A default segment starting at 0. I don't know that I want to analyze it right now. I mean, auto-analyze it. I want to look at it. Is this too much cat? Oh, that's interesting. Is this automatically identifying numbers that look like 32-bit? Like, I don't know what range it's looking at, but maybe 32-bit values that could be pointers. We also could look at how this is being loaded. The loader is not very complicated. Speaking of loader, we could just write down some stuff about the header, I guess. Really know these are pointers. Is that code? Oh, that might be code. Oh. And we're like setting up memory right here. So yeah, this starts with two 32-bit values that are probably, like, I'm guessing a base address and then a length of something. This is too small to be a length of the whole binary, but it might be a length of like a zeroed section, or it might be a length of something measured in pages. I don't know. Memory map. Let's use these tiny icons to add some stuff to the memory map. Pretty sure the loader would have zeroed that. I don't know. I mean, this isn't just the stack. wonder where that config file is. Config rom dot not time 24 hour. This does not run in DOS. It runs in an embedded operating system called PSOS, but it uses DOS-style path names. Well, when I say runs in an embedded OS, I mean this one binary is an application and effectively a library OS linked together. And the only other files on the disk are bootloader-related stuff and configuration files and bitmaps and other data files. It doesn't use dynamic libraries or like any kind of OS shell. Okay, anyway. I need to find some pointers that I can use to locate the code. There's a bunch of strings. It'd be cool if maybe some of these were pointers to strings. Oh. Is this code? Really? I don't know. This is weird code, but this is, I think this is disassembling correctly. These are I/O registers that are part of this system on chip. And we're doing something with CR3 and CR0 here. And then I forget what these ports are, but more I/O ports. Don't know what to do about these addresses yet. These might be MMIO, but I don't know. This is called in a bunch of places. How are we getting XREFs to this? Are these not absolute? That couldn't be right. Yeah, I wouldn't expect any code cross-references to be correct at this point, because I don't know what address the code's actually loaded at. And like these are relative. So these will point to the right thing, but it'll be using the wrong number in the disassembler. I'm just marking some stuff as code that like looks extremely like code. I mean, and some of this doesn't matter. Like these are just padding, no ops, but they look nicer if they're actually disassembled. I mean, it seems likely that this first number is the load address, but that's really just a guess. I want to find a number that looks like a pointer to code. I mean, specifically, I want to find a number that looks like it's being used in a pointer to code kind of way, and then that'll tell me. That'll hopefully at least give me some clues about where the code's loaded. It might very well be easier to start with the loader than by just looking for clues in here, though. Yeah, how far did we get into the loader? That's this psos boot.sys, which we'd already looked at a little bit. And so this is mostly 16-bit code. The very last thing it does is it switches into protected mode. That would also be a great reason for the load address to be right above 64K. Like just have the 16-bit code occupy the lower 64K where it's, you know, easy to reach everything, and then give the 32-bit code everything above that. But let's see if that's even real. So yeah, I'm pretty sure I got this address by looking at how this file was loaded by the boot sector. So that address should be real. This is likely a section of the bootloader that's designed to be customized. Like we can treat this as data, but other software might treat this as like a config file. What is this application load address? Should be above some number. Okay. It's interesting. These are both at the 64K, like 10,000 hex here. It's just this one included it in the string, and this one like used a printf. Can I just call this printf? All sorts of new smells here from the rain. Hasn't rained in a while. I'm doing this check twice. I'm wondering if there are two different load paths, or maybe it's checking the beginning and the end of the image. This is like a number of sectors we're multiplying by 512. Just getting move Z and C move confused. These are completely different instructions. This is move with 0 extend, and C move is conditional move. Anyway, is this maybe a header that defines a length in pages or something? This looks kind of like there's a pattern of adding a base to a length and then calling load address, but here the length is just 512. This is looking kind of like my start address and end address theory. I don't know about this header pointer. Ooh, lots of people use that. Only one place writing to it, though. This is looking like it is actually the load base address. Like whatever header this is reading is bigger than what I've seen in the file so far. grow the RAM or the data segment I added a little bit. It'd be interesting to see how seriously they take their protective counter in the code here. There's probably a string table here somewhere that, like, if I'm looking for pointers, I might as well look for the strings. And if I assume that they mapped this at a nice round offset, I might just be able to search for these bottom couple of bytes of a couple of strings. Oh, I think these are messages that it uses for the printouts that it makes. Yeah. I don't know if these would even be a string in a string table. There's probably just some code that refers to these. Only one instance of that. Maybe this is a string table. Two 04754. Okay. I think that was the start address, but it was not in units of bytes. It was in units of 16-byte paragraphs. So the start address is actually shifted over by one nibble and then added to what we've got here. So the offset in the file for this string was 104.754, and I just searched for the bytes 4754, assuming there would be some arbitrary high bytes there. And then I found that at 204074. So I think we can just do that then. Move block. Okay. So some of that stuff we thought was RW data is actually in this segment. Let's just temporarily delete that other segment. Yeah, the cat cam this is my nicest camera. Of course we put it on the most important job. All right, what do we have now? Pointer loop. Let's just not have this be a reference at all. It's fine, some things can just be numbers. I don't know why it's an angry number now. Why so angry? Oh, because it's a pointer without a reference. Interesting. I guess. Okay, I'll just redefine it. Okay, so what are we doing with the stack here? Yeah, no, like what are we doing with stack? Did they just ship a bunch of zeros for the stack to hang out in? Is that what we're doing here? These were on the compact flash card. Normally you would separate out the zeros into a separate segment that you don't actually have to store. I'm just going to call this stack top. I don't know if they're going to set up multiple stacks here. 0 LDT. It's like something kind of boot flag shaped, but I'm not even going to label that right now. Cool, we're just immediately going into some hardware setup here. Okay, we might just have string references at this point. Go take a look at that. Maybe we run an analyze. Yeah, now that we've got the memory set up, auto-analyze actually should be able to find a bunch of stuff. Analyzing. Yes, this is less interactive of a disassembler when it's busy analyzing. This is also still running on my kind of pokey machine. I haven't really got like a demo environment set up on the other workstation that I just installed Arch Linux on today. But it's busy transcoding recordings for this stream. So there's that at least. It's a nice feline comment from the chat. Yes, he's a very nice cat, I agree. I'm trying to disassemble this, but it's just, there's probably a queue of operations. Oh yeah, I can't even save it. Let's just leave it alone for a minute. different chair. Oh, did it do the thing? Ooh, yeah, look at all the strings. What was that? Authentic AMD. That's funny. I wonder if they're actually checking the CPU type on this. It wouldn't really surprise me. It seems like they've got some sort of DRM flavored stuff going on in here. They're sending a non-standard command to the compact flash card, which is the first thing that keeps it from booting if you try to run the image in a VM. I'm sure there would be other things like, I'm sure it only supports one graphics chip, and as we're seeing, it immediately starts talking to registers that are specific to this system on chip. Okay, let's look for that activate string again, maybe. These aren't the ones I was looking for. Oh, see here, LCD text messages index. That seems useful. We could probably just follow that one back. I was looking for the actual LCD messages. They are kind of distinctive because I think they have spaces padding them to the size of the LCD. Comb. Maybe there's like a booting message that we should be able to find, right? Maybe that would be easier. Maybe all the LCD messages are not in this table yet. Let's look for them in the elsewhere. How many different copies of Please Wait are in this program? I think these are the LCD messages. Oh, they were identified as code somehow. Ooh. Yeah, that's a mess. Oh gosh. How big a mess is this? Earl. Oh. Where's Duke? Oh. I'll move the camera in just a sec. Just rerun the string finding part of that. This is so... I don't know, just like the things they think are important are silly. Like, I think this is text for one of the voting result printouts, and they're listing like the separate 8-bit values that are stored in the EEPROM as a verification. Like it's like a small amount of protection against accidental failures is all they really have. It's like, no, we'll just store 2 copies of it in 2 EEPROMs. That's all the security we need. My eye was drawn here because of all the spaces, because I was looking for the text LCD strings, but these are for the printer, which also have a lot of just like built-in spacing. This is a text LCD message. Printer paper is low. It would make sense if there was no reference to this setting video brightness message, since I've seen some other evidence that this may have at one point had a backlight or a screen software contrast adjustment, but that doesn't seem to be currently enabled. Why are there so many references to printer paper as low? So there was a report from, I think, Black Box Voting about, or no, maybe it wasn't them. They released some documentation that I was looking at. There was also a report from somebody who did like a code analysis on this, and I'm assuming they were looking at source code and not disassembling it. But yeah, they had a bunch of complaints about the security and the overall code quality here, so I'm not expecting this to be especially nice code or well thought out. And so I'm already like, is this really copy pasta? Are there just 3 copies of this printer paper is out code? Like, what are we even doing here? I don't know what compiler, but I'm assuming all of this was written in C. I don't think they'd have any reason to write anything in this file in assembly. They might have used inline assembly for some of that I/O stuff, maybe the entry point stuff. Yeah, probably the entry point stuff was in assembly, but most of this application I'm expecting would have been written with some kind of C compiler, probably not actually GCC like I told Gidra, probably, I don't know, some commercial compiler. It's just weird. I mean, I wonder if these are supposed to be separate functions. Let's look at something that isn't printer paper. Maybe printer paper is cursed. Let's look for something that should be sensible, like can't init the file system or system hardware test passed. Of course, I don't know why there are 3 copies of the system hardware test passed. This might be a higher level message thing that tries to give you some context about how to recover from the message. I don't know. Here's a lower level message function. Am I not labeling these correctly? Oh, it's under L for LCD message func. But I also have load. It's important that all the L's stay together. I'm going to have more than 4 functions eventually. Are we into some OS internals now? No? Oh, there's a question about the printouts. Yeah, it does printouts for a few things. The printer is mostly there to print out official vote summaries. So it'll print out a list of what the machine recorded, and then you'll have some official people sign it, and then you'll like store this little piece of thermal paper in your permanent record, I guess. It's kind of weird. Yeah, it's like a little thermal receipt printer, and it just uses ASCII. I don't think it even uses any special characters. It's just a text printer on a parallel port. Oh, what are we doing here? There's a pointer to this authentic AMD string. Are we doing something that requires CPU model detection here? Why? Okay, this function is probably just something about CPU type detection then. Actually, both of these are related to CPU type detection. Try to share the screen here between the cat and the disassembly in a equitable manner. Okay, so that's interesting. This is a little easier to see what it's doing in the decompilation for this function. So that thing that I was following into what's now called CPU type detect 2, that's actually just returning a parameter that gets passed into this function pointer here. It's pretty weird. Oh, we've got some rights to this. It's getting a little chilly here, so I set up that heated blanket so that little warm pad is kind of, or that little blue pad is kind of warm for Took. Ah, cool. I actually wanted to see this whole thing. Why is it cutting it off? Ah, cool. Data. Is it not going to fill in this value for me? This time it filled it in for me. Interesting. That's interesting. So they're testing whether you're on AMD or Cyrix, and then I don't know if these two things are related, but they're also switching between these two implementations, one of which just returns an error, I guess. So that's a stub implementation. Ooh, we've got a message from LCD driver. Unknown LCD command in param1. Oh. So I guess that was a pointer to the current LCD driver, and this is like an LCD driver IO control or LCD driver command. Cool, and then this already is looking useful here, right? Like there's a function they call with a string that seems like it represents an empty screen. Maybe it's sending that to the LCD, maybe it's storing that as some representation of what the LCD might have already had, but I bet we open this up and it's going to be sending it. Yep. Those are ports 210 and 212. Nice little hard-coded delay there. I guess this is not internal. This is just like a general write. So it looks like we call this within the driver to write stuff, but then there's also a command that just lets you write arbitrary data to the LCD here. Ooh, and then there are some commands that talk directly to the I/O port. It would be sensible if this were either the backlight control or on these on this particular kind of text LCD, the HD44780 style, there's a pin that switches you between sending like actual characters to go to the screen and sending command bytes. So it's possible they would have an out-of-band switch like this for that. So add these to our I/O port notes. Oh, does this take a parameter? Ooh, is this initialization? Gosh, it is actually really convenient having a decompiler when they start throwing like multiplication and division and, you know, little hard-coded loops like this at you. Like, this is just a random delay loop. I don't know why it's written like this, probably because it made sense with the macros they used to write this. Actually, they're doing... This looks a little bit like fixed point scaling, except, you know, normally they would use a power of 2 on the divisor instead of doing an actual divide. But I'm going to call this like LCD delay length. Oh, I guess specifically the startup delay. Actually, I don't know if this is LCD driver related even, or if this is just like something about the system speed. Who else refers to that? Yeah, that's got to be some kind of general purpose, like the old school Linux BOGO MIPS value, like it measures how fast the CPU delays, or how fast the CPU is and how long the delays need to be. That's the LCD init that we were just looking at. This is cool. This is like a juicy function here. I wonder if this is like a formatted version of the other message thing. Oh, maybe this is like a panic. It's like it's doing something which includes writing the message to the debug or to the text LCD. But then we're doing some other stuff. This doesn't seem to be like building a string so much as like checking some flags and deciding what else to do. Oh. It's nice when we have strings that tell you what the function name is. It looks like a fatal error routine, right? So now we can see all the fatal error locations. Like, oh, I can't init the graphics subsystem. Okay, maybe we should go back to the LCD driver. I don't know, but the power up is so interesting. It would actually maybe be useful to look up some of these registers. Like some of this is stuff that would be documented in the system on chip. Some of it's going to be GPIOs probably. We could try to figure out what those commands were, I guess. That's command 12 going to the LCD. It's possible that they just never use command mode on the LCD. No, we should see it use command mode to initialize, because these Hitachi style LCDs, they initialize in a single line mode, and you can actually see that it's not driving the bottom half of the LCD until it initializes that. Let's go back to the LCD driver. Is this going to be a delay of some sort? Yeah. This is a weird little function. The decompiler was simplifying it quite a bit. That looks, yeah, that's weird. So we get a parameter, that's what comes in EAX. Or no, it comes in on the stack. We move it into ECX here, and EAX. Like, stuff like this confuses me. A compiler shouldn't generate code like this. So either this was like handwritten somehow. Maybe their compiler has optimization disabled? I don't know. This isn't self-modifying, is it? Huh. This is probably a delay, and this is going to be something that our timer ISR writes to, like a global tick counter. Yeah, okay, this makes more sense. The decompiler was simplifying this code too much. Like, it was assuming, I think, that this is a read-only value, and definitely not. I mean, like, if you look at the disassembly, or if you look at the decompiler output, this is definitely an infinite loop. But looking at the assembly, this looks more like a spin lock kind of thing. Yeah, this is going to be like a timer tick count. Yeah. That makes much more sense. Into memory. Okay, LCD driver. So a bunch of delays. Oh, I wonder if this is going to be like at the command/data bit. Maybe it's an error flag. Okay, let's look at how the actual bytes go out. We've been putting that off. Another little subfunction, and this is almost a leaf. Or at least it doesn't have stuff in it that we haven't analyzed. Oh! What's the deal with the parameter here? Is it really just a Boolean? This is another delay loop, but with like a way to get out, or maybe a wait with a timeout. Yeah, I think this is another function that doesn't make any sense in the decompiled version. Oh yeah, this is definitely a timeout. So we've got like a success versus failure flag here. So if this bit is not set, we continue waiting. If it is set, we set this flag to 1 and return through that path. Okay, that's what it was also calling after sending those C or F. Given that we're waiting for some kind of confirmation, I doubt this is just like a backlight related thing. The backlight, I don't even know if the backlight has software control. I think it might just be on all the time. And then this 1E is a timeout. And the return value is a success or failure. I want to label this, but I don't even really know what kind of error reporting this is. This looks like it's just logging it somewhere. He's just perfectly curled up like a little bean. There's a question about how it stores votes. The usual way is on these PC card shaped memory devices, which might very well be normal PCMCIA cards. I haven't really looked into that. I'm pretty sure they were designed to just write files onto PC cards that you could then read using special software on a laptop. And then I think they stored a backup of that in the EEPROM memory in some form, although there isn't much memory, so I don't know how much of that they store. There isn't much data to store anyway. I mean, there's a list of candidates, there's a bunch of vote counters, there's like counters that are designed to be reset at different times. It's not very big. Is this an arithmetic utility? That's interesting. So we always return the first parameter. Oh, is this supposed to be like a print function? Like a string copy. Yeah, this might just be stir-in copy. I'm not actually going to call it stir-in copy unless I know it's actually that, but sure. This thing that I labeled in a init flag might actually be a buffer. This is getting a copy of whatever was in there. I wonder if this is implemented on that PLD. I was just thinking about where this would actually be attached. These Hitachi HD44780 style displays are actually really easy to interface directly with something like an ISA bus, though. So this this probably is literally just the ISA bus decoding ANDed with IO write is turning into the strobe signal for the LCD. Right, like so far we have 3 ports. There's 210 with a bunch of output bits. There's 211 with a status bit. And then 212 seems to be a data out. It is just weird that we would be waiting for a busy flag. These LCDs are usually write-only. I don't think the LCD itself would have any feedback to offer, so either this is just unrelated stuff that they're pulling here. I wonder if that's the button. I wonder if we're just doing a user interface thing where we're delaying and then waiting for, you know, like allowing you to click past the message. That could very well just be the button. No, why would we be doing that after? Like, this isn't after the message. This is in the byte loop. And we're checking on... Well, maybe we just do this in all of the timeout loops so that all the timeouts short circuit through if the activate button's pressed. Yeah, that's my current theory. Next time we have the machine on, we could just poke around and debug and try like reading and writing these ports to test our theory. So bvar1 here is our character. So we don't have, you know, we're not looking for nulls. 10 is special. What is that carriage return? Carriage return's 13, isn't it? Okay, why are we handling that here? So the messages did have carriage returns in them. And yeah, the Hitachi LCDs don't actually handle carriage returns. It would make more sense on that theory that they don't actually handle any commands. It would make more sense that they would just print the correct number of characters and just assume that it'll wrap at the right places. That is weird. Oh, are we keeping track of the screen location here? There's an extra long delay here, which might be for effect. It might also be because these displays are actually kind of slow at scrolling. Gosh, I wonder if port 210 is actually just writing commands. I'm going to open up the datasheet for the LCD controller in a sec. Yeah, maybe they aren't even bits. This is a classic LCD controller. We might very well have an actual HD44780 chip on this. There are also just tons of clones of this that use the same command set. Oh my gosh, there is a busy flag. I've never actually used the busy flag or seen a program use it. I forgot this existed. Gosh. Okay. Cool. Well, maybe we are actually just checking the HD4470D's busy flag. That's the right bit. It's in DB7 and like, gosh, this is just maybe very, very straightforwardly connected to the ISA bus. Did I have that polarity backwards? Looks like I had that polarity backwards. Okay, well in this case, yeah, I'm maybe expecting 210 to just be a command word and not a bit field. Okay, we were scrolling with 20. Or no, CO. Gosh, you can read data from the graphics memory. I totally forgot you could read from these LCDs. I don't think I've ever seen somebody connect the read-write pin. That's brilliant. Okay. That is not scroll, I guess. So C0, if I'm reading this right, would be a command to set the address to the second line. That would also explain why we're repeating the commands like this. Like that makes more sense than sending like a GPIO out multiple times. Like you'd really only do that if you were trying to do an intentional delay that was timed using the bus. Yeah, that's a function set command. So we're setting 8-bit mode to line, and we're picking a font. Yeah, okay, so this is a command write port. That is very straightforward. In that case, there's probably no weird initialization here. Like I haven't seen any GPIOs or other I/O accesses near this. So, I mean, and we can tell just by looking at the LCD that the LCD controller is powered on as soon as the system gets power. Like as soon as the system comes out of deep sleep and like the 5-volt and 3v3 buses go on, you can see the top half of the LCD kind of gain some contrast. And that's what these controllers do when they first get power, because they start up in a mode where they're not driving the second half of the LCD, and the LCD is empty. So you see like a completely blank bottom half of the screen and a top half of the screen that has just faint pixels that are not darkened but are like powered. Yeah, let's just look up the rest of these commands for fun, but this is definitely just a command port at this point. How do I split these windows? Like, I'm used to being able to drag this out, but that's not working for some reason. I guess I should just save this. Well, that should be the first thing we do after that LCD cable repair dries and we can flip this back over, is just test if this works, because this looks very simple. Like, I don't think there's anything magic about this. They either just generated the chip select for this on the PLD and then let the LCD controller itself deal with everything else, or they might even be getting the chip select from... There are a few ways they could be generating that. They could be using logic in the PLD. There are a couple of general purpose chip selects in the Super I/O chip, and I don't know what the constraints are in those, but maybe they can program that to do this. Cool, so 8 sets it's an entry mode set command that sets the cursor direction and the display shift, which is like the automatic scrolling. We have a 1, which clears the display. We have a 6, which is another entry mode set. Yeah, sorry, 8 was display on-off control. I think the 8 was actually turning the screen off during the initialization. So the 8 will turn it off, and then the C turns it back on. Right, like 8 is display off, 1 is clear display, 6 is entry mode set. And then we turn the display back on. And then 80 is setting the address back to the top of the screen. Or no, yeah, I was right, but it was highlighting the wrong line. This other one is the character generator RAM. So if you set the address to the character generator RAM, you can write custom characters, which is also pretty fun. There's not very much. I think you can store like 8 characters. So certainly not like an entire font, but enough for a handful of weird characters or like a bar graph display or something. And you can even animate them because, of course, it is just like a character generator. Well, I think that might be a good place to stop tonight. I'm trying to keep the individual streams from dragging on too much, and in exchange trying to do them regularly. But yeah, that looks pretty pretty explained at this point. So 210 is a command write port. In fact, we could even look at how the address bits are lined up here, right? So we have 2 bits for address. If it's 0, we have 2 bits for address, and we have a read-write bit. Let's put that in the table too. RW is 1 for read. Okay, and then we've got this other thing called register select, which is 0 for command mode and then 1 for data. Right? It seems like there might be a way to read the data back from the screen using the same method. So, like if we figure out how this is actually wired, like is that reading from port 212 maybe? Let's just figure this out. So this is port 210. Writing commands. 211, reading the busy flag. So read write flag is 1. RS is still 0. Oh, I guess you could just read from 212, right? I guess what I'm getting at is I don't know why 210 and 212 are different ports. So one hypothesis is that they're decoding anything in the 210 through 213 range, because that's kind of how you would chop the addresses up. And then, so you've got that low 2 bits to use for whatever. So you need one of those bits to select between the data and the command modes. So it looks like they've used bit A1 to drive the register select pin. So that would just be a direct wiring from a pin on the ISA bus to a pin on the LCD controller. So yeah, if that's true, then hypothetically maybe 212 and 213 act the same and 210 and 211 act the same. But it's also possible they wired this so that they would only actually have to decode IO writes for one address port and reads for the other port. So maybe they didn't actually implement all the combinations. Anyway, I think that's it for today's stream. A fellow Gidro enjoyer. Yeah, I'm pretty new at this. I haven't been doing reverse engineering extremely regularly ever, but it's something I tend to occasionally find myself doing bursts of. And so I've used IDA. I used to use it at work a little bit, so I have an ancient license that a former employer bought me, but I haven't used that in a while because it's super ancient and there's Ghidra now, which seems alright. Anyway, I've been trying to do these streams every day, so I'll be back here on the usual spots, on Twitch, on Diode Zone, on YouTube, on the Scanlime-in-Progress channel. And thanks to everyone on Patreon who kicks in a few bucks every month and keeps this going. Was kind of offline for a while doing studio upgrades and everything, but now I finally got something that I can do like a daily workflow on without it being terrible. So trying to actually do that. And I will see all of you next time. Happy hacking, folks.